everybody to this fourth episode of Advanced Excel session. In this tutorial, we'll deal with a creative problem. Here we can see a tank which is made up of cylindrical component and two spherical components. These mathematical equations you see here, they calculate the volume of a liquid when they are inserted to a height h in this tank. Our main job here is to calculate the height of liquid covered when the tank is filled up to a volume of, let's say, 100 gallon or 200 gallon and many more. So to deal with such type of problem, I have set up here a template where I have given this length of cylindrical portion as 12 feet and radius, which is the half of the diameter, to be of 3 feet, which means the total height of this tank where the liquid can be filled is 3 times 2, that is 6 feet. And I've converted the value of h into inches and feet, where we need to make initial guesses to use the tools like solver and goal-seek. And I have already plugged these equations in these cells, which gives me the total volume of the liquid when they are filled up to a depth of h. And I have converted this to gallons by multiplying with 7.8, because 1 cubic feet always equals 7.8 gallons. So let's get started. As learned in the previous screencast, we can use goal-seek and solver tools to solve such optimization problem. Let's begin with the goal-seek. I click on what if analysis and select the goal-seek. At first, I want to know what will be the height of liquid when it's filled up to a volume of 100 gallon. To determine that, I set the cell as B13 to a value of 100 gallons by changing the value height in inches, and it goes through and spits out the solution as 5.4 inches. And I can copy that and simply paste here, and again I can run the goal-seek in the similar ways to find the height for the value of volume to be 200 by changing h again, and it goes through and spits out me the value of h as around 8.5 inches. I copy and paste it here. Suppose I want to know the total volume of the liquid here, then I can calculate it by let's say if the radius comes out to be 3 feet, then the total height will be 6 feet. I press here 6 and it tabulates me to the value of total capacity of tank as around 3,300 gallons. That means with the increment of 100, I have to drag it down to 40th cell for analyzing the total volumes. And if we keep on using the goal-seek, then we need to perform such similar actions for about again 46 times. So it's quite doable, but will take a lot of time to fill up these tables. So this is what I find to be the drawback of goal-seek. Likewise, we can also use the solver tool to solve this problem. For that, we need to make an initial guess, let's say to a height of 5.4 when the volume of gallons turns out to be 100. We click on solver tool, and in this tab we select the total gallon cell to a value of 100, and of course it's by changing the height in inches. We click on solve and it spits out the value. We press and copy and paste it to the h height via solver tool column. Likewise, we can run the algorithm again to a value of 200. Now, if you have noticed, one thing good about the solver tool is it remembers the previous scenario, and if we keep on solving this problem via the solver tool, then you don't need to assign the uh, objective tab, and by changing variable cell tab again and again, which had to be done if you have selected the goal seek tool for the process. So it's good about solver tool. After assigning the value of 200, you simply click on solve, and it spits you the value of h, and you copy and paste it in this cell. Okay, this is doable, but to fill up this data, you need to run this algorithm to a couple more times, and also if you want to perform the case on varying length, then it will not automate the table here. So this is not what we call a live solution, and this is what I find the drawbacks of tools like GoalSeek and Solver. So to know how to automate these sorts of problem, follow me in the next episode.